Welcome everyone. Thank you for joining us for today's FIBERTalk webinar series. I'm Rosafi Alam here with you today. I hope everyone is doing fine. Today our webinar will be focused on 5G early deployments, outdoors and indoors, with real-world use cases, along with two distinguished speakers from the industry. Our first colleague for today is Kiran Solipuram, the General Manager APAC for Senko Advanced Components. And the second speaker for today would be Renee Mateparae, the Tribe Lead Technology Evolution from Spark New Zealand, the largest mobile operator in New Zealand. Both of the speakers will have 25 minutes each, and then we will have the Q&A session. If you have any questions during the presentation, please type those in the questions box, and we will try our best to discuss those with our speakers. Now we will move to the first presentation for today by Kiran Solipuram. Kiran is a globally recognized ICT industry leader with 21 years of core experiences working for multinational CSPs, ISPs, utility operators, mobile operators, metro operators across Asia Pacific, North America, and Europe. His key focus for today's presentation will be to examine 5G key trends, drivers, network architecture, design aspects, and outdoor deployment opportunities. In addition, he would emphasize on densification of 5G, along with bringing 5G network to indoors, enabling users for uninterrupted enhanced mobile broadband services and device-to-device IoT connectivity. So please welcome Kiran. I'm giving the presenter mode to Kiran. Please welcome Kiran.
Thank you, Safi. Thank you for having me on board. So it's really excited today that we are here. We gathered here online webinar session from Fiber to the Home Council. Thanks to the council management organizing such an exciting event today. So yeah, so thank you very much for that again, all participants, and welcome to the Fiber to the Home webinar. So today I'm going to talk about the 5G network, 5G rollout deployments, especially in terms of the deployment when it comes to the outdoors and indoors, and what are the challenges, and how to resolve the challenges. What are the opportunities that we can realize? These are some of the challenges, opportunities that we realized from our early deployments. So I'm going to talk about those pointers, those challenges and opportunities. So we will be seeing two distinguished areas. One is outdoors and indoors. The content that we are going to see today is going to classify these two different areas. So as you all are aware, 5G is a really exciting word. So fifth generation of the mobile communications. So it creates a lot of upcoming, and it creates very interesting cases, scenarios, and exciting for the end mobile broadband user. So 5G, the first the benefit that everyone started talking about is enhanced mobile broadband. Compared to the third generation and fourth generation LTE, the enhanced mobile broadband gives it enriches the real-time experience or real-time 4K, 8K video streaming on mobile devices. At the same time, connecting a massive Internet of Things, massive devices, massive connectivity, device-to-device connectivity, and enabling a true real-time experience. In addition to the Industry 4, the automation of the industries using the low latency applications. At the same time, thanks to network virtualization technology that actually makes edge computing more possible, the processing of with the relation of the low latency, the processing of the network functions on the edge computing is something the 5G enables. So 5G is really exciting, but however, there are definitely challenges. It's not that easy that the 5G can realize these all challenges just like that. So the challenges are there. However, operators and the deployment providers and the vendors, they are actually doing their part to address those challenges. So If we look at the 5G, the context technology view, the technology is more on the three different topics that 5G always enhances, 5G always focus. The first one is enhanced mobile broadband. That's more enabling the applications of ultra high definition videos and virtual or augmented reality and immersive broadcasting. The next is critical machine to machine type communications, or machine to machine communications, machine to things communications. So something like that. So that actually enabling the applications of intelligent traffic system, smart grids, remote manufacturing, training, medical. So with a high ultra low latency bandwidth, this critical machine type communications is possible. And massive communications, and another area that 5G looks into this is the low cost, low energy, massive machine type communications, deploying more and more, connecting more and more in the areas of smart cities and in the manufacturing industry with the logistics and tracking the information, fleet management, and similar applications. So these are the exciting things that in technology point of view, how the 5G would bring. So what does that mean when we talk about all these features, we talk about all these advanced, exciting applications enabling 5G? What does that mean for network point of view in terms of the network deployment point of view? It's two things. One is adding more backhaul, adding more bandwidth is another thing. So these two things, we are going to see how these two things will be addressed when they deployed internally and externally or outdoors. So when we look at the 5G, 5G can be deployed in a three distinguished areas. One is macro cells, another one is micro cells. Micro cells, especially with the 5G new radios, and micro cells with the 5G small cells. At the same time, bringing 5G to indoors in terms of the distributed antenna systems. These three different areas. So if you look at the deployment scenarios, the scenario is based on four different classifications. The dense urban is more on the broadband home users or home residential users. And then next one is the future, the area is future enterprise broadband, mobile broadband connectivity using the future smart offices. The next third one is the dense urban broadband that actually gives the high crowded, high density areas like stadiums or shopping malls. The next one, the fourth area is mobile broadband in vehicle connectivity, mission type connectivity, machine to machine connectivity, machine to things connectivity, machine to the traffic connectivity. So that area, these four deployment areas. So however, in overall, if you look at these four different deployment areas, the classification is outdoors and indoors. So let's look at the outdoor challenges. What are the challenges exist in outdoors when 5G is deployed, and how to address those challenges? So the key challenges what we see is planning and design of the new radios, planning and design of the small cells, densification of the small cells, at the same time deployment of the small cells, powering of the small cells when you deploy, and what are the backhaul and fronthaul options available to enable true 5G. So when we really look at into cellular planning, when it comes to the 5G actually redefines the cellular planning from fourth generation or predecessor generations. The first, the cellular 4G is more about focusing on the one microstation on one area, and then classifying and then focusing on larger areas. But when it comes to the 5G for fifth generation, it is more on the densification of the cellular radio network, cellular radios, more and more densification of the cellulars. So when we look at the small cells deployment, when the densification is more deploying the radios, the same time focusing on the compacted components, because the more densification, because of the more radios needs to be deployed. So the size of the radios are also matters. The same time, the next challenge that is the site availability, and the same time site matching the site to the radio planning, matching the site to the radio network. Backhauls, at the same time with the cost for the implementation, acquiring the site and deploying the site is something to a cost. At the same time, for the operator, what is the return on investment by end of the day once the site the small cell is deployed. At the same time, there is a perspective. There is a view in the market that the radios are really not good for public health. So legislation and compliance matters here. Although the radios are deployed properly and the network backhaul is properly available, but the legislation compliance doesn't meet, then the deployment of the small cells, it really face a lot of challenges. So the next one, the powering. How do we power the radios? When we talk about 5Gs are more about deploying the more and more radios. Then powering is very important. So that's the reason what we say is planning and designing for the deployment of the 5G small cells is very key. So designing elements, especially when it comes to the designing of the 5G network or small cells, or densification of the small cells is more on the site planning and acquisition of the sites related matter, and the radios transmission path, the path, whether it needs to be radio transmission or it needs to be any mobile backhaul, or any certifications is another matter. That's something structural certifications, electromagnetic interference certifications, and giving detailed information about the towers and especially the radios and the radios positions, radios alignment, and including bill of materials, and creating the schematics for the backhaul to the front haul to the small cells. So these are some of the key elements actually needs to be focused when 5G needs to be deployed. And what we see is 5G definitely requires, whether it is a debate or not, but 5G really requires a lot of investment for optical fiber network. So 5G front haul definitely needs of the optical fibers, because the optical fiber only has the capacity to enable those true real enhanced mobile broadband or ultra low latency applications that we seen in the beginning of this presentation. So however, if you look at the graph, the second graph, the investments on microwave and fiber optic front hauls are different. So when the microwave is preferred as a front haul, the invest might be a bit lower. But when you focus on the fiber optics, the front haul, the invest might be definitely higher, or might be a bit longer. But however, there is an research firm analyzed. So around 1.339 million of the fiber miles needs to be deployed if at all they have to cover 25 metropolitan 5G small cell areas, if assumed they are all on fiber backhaul, fiber front haul. That kind of investment would go. But how do we resolve? Because microwave is not going to give that kind of front haul that we are talking about, low latency, high ultra speed broadband. At the same time, fiber deployment is really it's time consuming. It might definitely need some time. So how do we address these challenges? The challenge is like there are technologies available. There are the vendors are making high density equipment. So if you look at here, the backhaul is fiber to the backhaul areas, and the next area is the front haul, connecting the microwaves, radios, cell towers. So different areas using the different techniques, fiber techniques, either point-to-point, Ethernet over CWDM or DWDM technique, or existing passive optical networks using our NG-PON or advanced next generation 10G or 40 gigabits PON networks, leveraging the WDM techniques. So these fiber backhauls or front hauls can be given to the new radios, given to the small cells. That way, the fiber deployment challenges needs to be deployment challenges can be achieved. The innovations are some of the innovations of the vendors. They are making more compacted WDM jointers, WDM couplers, where the 5G can be spaced using the different dense wavelengths, using the compacted the fibers, using the information that can be given to the 5G small cells. So the next challenge is the powering. What we see is 5G is not really just a macro cell, but also the deploying the small cells that as we learn. But coverage, as we go and deploy more and more 5G small cells, we definitely need to give the need to power these the radios. How do we power those radios? If you look at the graph here, so typical 5G radios are generally for 5G, it consumes around 11,500 watts of the power. So how do we make sure we give a power in a compacted environment where the radios are very small, where the more densification of the cells or radios are deployed. So the power feeding is another area that needs to be focused, that needs to be addressed. So especially the space constraints when it comes to 5G small cells deployments, and the number of small cells are more, and access to the land or access to the location might be difficult because of the access issues. At the same time, local power supply may not be available. We cannot assume the local power supply is always available for the small cells, although they are on the street poles, they are on the buildings, but still the local power supply may not be available. That may be an additional challenge. And at the same time, negotiating the building owners with the power supplies. And these are the key elements that when it comes to the powering of the 5G small cells. So that's the reason there are hybrid cables, there are hybrid connectors, hybrid power plus electrical connectors are available in the market. So vendors are making the hybrid connectors to make sure the 5G is the backhaul deployment, the front haul deployment, along with the power club together, combined together, leveraging the advanced technical technologies, mixing up these two things and powering up and the feeding up the small cells is another another advantage or another innovation in a 5G small cells deployment. When it comes to the indoors, the indoor challenges are a bit different compared to the outdoor challenges. Indoor is more something to deal with the architecture and the technologies, or how do we enable 5G? Because for indoor, we all experience the Wi-Fi. Wi-Fi is main thing in indoors, but how do we make Wi-Fi is enabled with 5G technologies to realize that indoor machine-to-machine connectivity, our indoor Internet of Things are working, are really realized. So these are some of the challenges. We look into that, and we'll see how these challenges are addressed. So if you look at the indoors, we generally live in a connected society. The connected society, when we go indoors, stadiums, malls, or shopping complexes, or inside buildings, or even enterprises environments, indoors and enterprise environment buildings, the indoors are connected. But however, we really don't realize that there are antennas, there are cameras, there are equipments, there are mobile connectivity equipments already are being deployed. So these actually antennas enable the 5G networks bringing into indoors. If we look at the indoors, 60 to 80% of the mobile traffic is generated indoors. The people who ever work or they do work, they stay indoors. 60 to 80% of the traffic is generated from indoors. And out of that 60 to 80% of the traffic, 80% are voice calls and 90% of data usage from the mobile broadband. So that means the 5G should go inside the doors, indoors. Then only the real-time applications or high, ultra-low latency or enhanced mobile broadband applications, related applications will be possible to enable. However, at the same time, a recent COVID situation has indeed created a prolonged effect on critical business process because majority of the workforce started working from home. Again, this is another indoor scenario. So indoor usage for the broadband connectivity, either we say fixed broadband or mobile broadband, the broadband connectivity is increasing.
Kiran, your audio is very low.
Oh, so is it clear now?
Yes.
So looking at the indoors, how do we bring the 5G connectivity to inside the buildings? So there is a unique challenge in the indoors when the building materials actually, the building materials are really very good for living for the people, but the materials are really not good for radio transmissions. So they actually block the signals, they stop the signals, the high frequency ranges, they don't actually allow signals to reach distances. So that's the different challenge. Those are some of the different challenges when it comes to the 5G deployments in indoors, inside the buildings. So 5G, when 5G needs to come inside, when the goal should be improving of the coverage, improving of the capacity, improving the quality of service. These three goals should be kept in mind when the 5G needs to be 5G should come inside the buildings. So when it comes to 5G inside the buildings, it should be able to enable, or it should be able to enable access multi-operator cellular technologies, not only just one operator cellular technology. The end user should be able to access the technology from anywhere to anywhere, any corner of the building or any corner of the anywhere inside the house or home or building or stadium, mall, whatever indoor applications you talk about, those needs to be enabled. So in building 5G experience, if at all we need to bring, there are three different things possible. There are three different technologies available. One is hybrid cellular, and another one is passive cellular. Another one is a mix of the hybrid and passive cellular, while we still enable 4G LTE networks and connect 5G networks, at the same time bringing Wi-Fi experience with a 5G mobile network connectivity. So that's if you look at the different scenarios how we can deploy the 5G in indoors. The passive DAS, passive distributed antenna system, that actually enables using the RF feeder network, distribution network, everything is a passive network. That way the cost is less, and deployment cost is less, and easy and quick to deploy. The next scenario that we can see is the active distributed antenna system, antenna model, where the active fiber feeder and the same time distribution and antennas are active. That way the fiber network gets inside the buildings and then gets connected to the active antennas. This scenario is really good when it comes to the high broadband applications, high ultra low latency applications, or we really want to experience a inside building Internet of Things, machine-to-machine connectivity when we want to do. And the final the deployment that we can see is hybrids. Because of the cost, because of the deployment timelines, active antenna system may not be really possible in some locations, some areas. That way operators prefer the hybrid antenna distribution antenna system rollout. So they use active fiber feeder, still they go with a passive antennas, passive distribution, where they are already exist in the buildings. So that way it's a mix of different infrastructure to deploy the network, make the 5G applications realized, true applications realized. So another one of the case study what we look at here, the 5G applications using the passive and active components. So we rolled out to one of the mining area where we used power and the fiber feeder connectivity, hybrid connector cables, using the power over Ethernet cables, using the RF and different fiber optic multi-mode WDM technologies. Using those techniques, we actually enabled the real-time application of underground mining network where the vehicles are monitored. So this is one of the case study that 5G actually made enabled from the real-time applications and from recent deployment. So conclusion is 5G is actually exciting. 5G makes everything possible that we are talking about, the high-end applications, very low latency applications, and in different industries, including the commercials, domestic, education, hospitality, and mining, military. Any industry you take, the industry is moving in a highly connected world. So the point here is the 5G is necessarily required to connect the world, to deploy into the world. But however, the challenges needs to be addressed with the cooperation of the operators, cooperation of the vendors, cooperation of the consultants. So that way, at the same time, compliance and the legislation needs to be aligned so that the 5G deployments will see a good light in the future. Thank you. Rusafi, any questions and answers session now, or we have that later?
We have started getting questions, but we will have a combined session for the Q&A.
No
later
worries.
on.
Thank you. Thank you.
Okay. Thanks. Great, Kiran. Great presentation. Thanks for the insights of the 5G technologies. Now we will move to our second presentation for today, which will be presented by Renee Mateparae, the Tribe Lead Technology Evolution from Spark New Zealand, the leading telecom operator in New Zealand. As Tribe Lead for Technology Evolution at Spark, New Zealand's leading telecommunication provider, Renee is responsible for delivery of Spark's smart network strategic programs. This includes the programs such as 5G rollout, Spark's IoT business, 4G enhancement program, and the evolution of Spark's fixed transport and access and aggregation network. Regarding her presentation, Spark launched their 5G lab in mid-2018 and since then has been trialing 5G with customers in the lab to prove out the value of 5G. Renee will share some of the emerging use cases that the team at Spark have delivered in collaboration with their customers, what 5G capabilities are required to enable these use cases over time, and an early view on where the biggest potential lies for 5G commercialization. So please welcome Renee, our second speaker for today. I'm giving the presenter mode to you. Please welcome Renee.
Thanks very much, Yusafi. Hi, everyone.
Slides are okay, yeah.
Great. So I'm here today to give an operator perspective on some of the real world 5G use cases we're seeing as we begin rolling out 5G in New Zealand. As Yusafi mentioned, Spark is New Zealand's largest telecommunications and digital services company. We started our 5G journey well over 2 years ago, starting with our initial testing in our nation's capital, Wellington, in 2018, and opening our own 5G lab and collaboration space, which I'll talk to you about a little later. Last year, we were the first telecommunications company in New Zealand to switch on 5G commercial services for wireless broadband, and we've continued rolling out 5G in 2020. And the idea for today's presentation is to give you a sense of the types of use cases and things that we're using 5G for, both today, but also some early signs of innovations that we're looking to bring in over the next couple of years, or early use cases that we're getting visibility of. So at Spark, we've taken quite a targeted approach to how we roll out 5G. Rather than going for widespread coverage, we've been focusing on helping our customers to understand what value 5G can bring to their businesses through collaboration and through partnerships. So we believe that whilst there isn't a clear view at the moment around what the killer app will be for 5G, the best way to work this out is by working closely with other businesses so that we can test and learn about what 5G can do. But first off, I'll just take a bit of a step back, and I'm sure most of you on this webinar will know the G's very well. But if we just set some context, the first G was all about voice. All of a sudden you could make phone calls without a fixed line and without being tethered to a fixed location. So I'm pretty sure there would be some people on this call that may have had one of the impressive suitcase phones. Beyond that, we moved on to 2G, and that was very much around text messages. The killer apps in 2G that we saw were SMS and the Snake game on Nokia, which I'm sure that some of you remember. 3G brought us the BlackBerry and our first foray into mobile data. So this gave us the ability so that we could wirelessly sync our calendars, our emails, and meant we didn't have to go back to the laptop to make sure that we were heading to the right meeting next. So it was a real revolution for business users. When we moved into 4G, the killer app is relatively well accepted as being video streaming. So there was a huge rise in the video streaming services as a result of 4G, so things like YouTube and Netflix, but it was really a lot more than just video streaming, everything from Uber to Spotify to Pokemon Go. And so what we're thinking 5G is, if you think of that degree of change from 3G to 4G, 5G is really about how we take our user experience to the next level. We particularly see 4G as having a lot of impact in the consumer space, but for us, 5G has got huge impact for the B2B space and our corporate and enterprise customers in particular. So I'm just going to play a quick video to give you an overview of our 5G lab. So one moment. And this is what we played for our customers to help them start the ideation process around 5G.
5G will open up a world of possibilities for New Zealanders that will transform our lives. With the potential to be at least 100 times faster than 4G and slash latency to 1,000th of a second, 5G will deliver more data and better performance than its predecessors. It will enable revolutionary technologies that rely on fast and reliable real-time communication with everything connected. Automated vehicles, smart machinery, civic infrastructure, and immersive experiences like augmented and virtual reality. This ground shift in the way the world will work will fundamentally change the economics of digital business models. With our partners, we have assembled a range of hands-on demonstrations to give you a taste of how 5G could change our everyday lives and help businesses find an edge. All in an environment dedicated to the advancement of 5G technology. We call it the Spark 5G Lab. Welcome.
So that was just to give you a taster of our 5G lab and what we were trying to achieve and innovate around with our customers. In terms of the results of the 5G lab, it was open for about 18 months. It's just recently closed. We had just under 3,500 visitors through on over 400 different tours from all different businesses around New Zealand, from small to corporate and enterprise and government customers. We did actually have a collaboration space that was a part of the lab, and we had 10 different companies from very different industries come in and experiment with us on our 5G test network around how 5G could disrupt and change their industry. And we would have 12 demos generally going at any one time. The idea of talking you guys through some of the use cases and good-looking use cases that we've developed with our customers is to give you an idea of what are the types of speeds, what type of latency and things that would be required, and particularly when you're looking at how we build out and deploy these networks, as Kiran spoke about earlier. So first off, I'll start with one of our early collaboration partners. I've got 5 different use cases that I'll talk you through. A couple are spoken through videos and a few I'll just talk to. The first was a partnership that we did with a charity called the Patience Project. The mission of the Patience Project is to connect sick kids to their classroom in real time from either the hospital or their homes. And I'll just play the video for you now.
Ben.
Hey, David.
Welcome to my new driverless car.
Oh, I like it. Look at that.
If we were going to get a little bit poetical, what would you say your driverless car is?
Well, my driverless car is connecting sick kids in real time with their classmates.
That's pretty cool.
Well, the Patience Project was an initiative that I came up with after the death of my son and watching him go through long-term treatment and the social isolation that he had during that time. So we put a 360-degree live streaming camera in the classroom in the same place that the kid normally would be. We give the kid a virtual reality headset and then we live stream that back to the kid, whether they're in hospital or at home.
Potentially, how would 5G help your system that you've set up?
Well, I'm genuinely excited about 5G because what we want to introduce is a true ability to have two-way conversation And to do that, we need faster response across the network, and 5G could enable us to do that wirelessly.
Hopefully we've got you thinking about the opportunities 5G presents for your business and asking this question. What's your driverless car? Ben.
Seeing some good Kiwi accents there. I think the Patience project was particularly exciting as well once you think about giving the ability for sick kids to also be able to move around wirelessly. So the solution that's being developed currently is based on a fixed connection, and so they're fixed to their seat in the classroom, but part of the benefit of 5G would be able to then have a device that was able to roam around the school so that they could have better interactions with their classmates. One of the other companies that we collaborated with is a company called Visual Air. They're based in South Auckland, Auckland being New Zealand's largest city, and they had the first 5G drone in New Zealand. So currently drones need to be flown within line of sight of the pilot, and 5G has the potential to change all of that. So if you can imagine a security system that was constantly monitoring a restricted area, such as a building site or a port from the air, not only could it alert the owners when there is a breach, but it can also provide evidence via a live stream. So a farmer can be notified about an incident hectares away, like trapped sheep jumping the fence. And the one shown here is an eye in the sky security solution that we trialed with Visual Air. So it's fitted with a 4K camera, a fisheye camera monitor, and these produce 360-degree spherical video and imagery to help with remote farm management. So we think that 5G will herald the arrival of autonomous drones because the network's low latency means the drones can receive information in real time and share information in real time. And this information can include hazards such as light aircraft nearby, and that means that the drones could react to avoid collisions. Because 5G uses large amounts of data at high speeds, it also enables the production of imagery with the sharpness and clarity that's needed for machine learning. So we've seen some really interesting use cases around analysis of building sites and that sort of thing. So you could use these on building sites, on campuses, and has the potential to then utilize the mobile edge compute capability to overlay an AI and machine learning capability to do things like counting people or cars and that sort of thing. Another use case or collaboration was with a company called Paymark in New Zealand. And so they were looking at the next generation of facial recognition technology to create an invisible payment experience. So what they were looking at doing was scanning hundreds of micro points that the system uses to identify the face and match it to a bank account. So when you would walk into the store, the vendor knows who you are, how you'll pay, and what you've ordered in the past. So it really delivers a complete step change in customer experience. The hardware behind the technology already exists. What 5G enables is the ability to scale this at a much lower cost because you're able to move some of the compute and analytics required to do the facial recognition away from the store locations and into central edge locations. The next one to talk about is a partnership we had with Toyota in New Zealand, a key partner of ours. The first city that we rolled out 5G from a mobile and wireless broadband perspective is a town called Palmerston North in New Zealand. And we partnered there with Toyota and their customer experience center, which is their national customer experience center is there, to create a virtual test drive experience. So Toyota worked with us to use 5G to further enhance their online retailing. So if you think of buying a car, customers are faced with a lot of options, and Toyota has a significant number of different vehicles, but also different configurations of vehicles. What they're seeing in their customer experience is that research plays such a big role, but a lot of it is now done online and before even going into the store. So they talk about customers previously might have made 6 visits to a store before buying a new car. It's now an average of 1.9, and therefore how they can take a virtual experience of their cars so that their customers can get a better sense of it is really important. So in the initial stages, we're testing the capability to have a 360-degree live screen cameras on and around the car so that customers can see the car and talk to a car expert and basically go on a virtual test drive of their exact model type that they are looking at buying, all from the comfort of their own home. So this is just an early proof of concept that we've had working. And so what you can see on the screen here is the customer experience. 5G was used where the test drive was occurring. And so the car was traveling around their test drive circuit and had three 360-degree cameras, one set up and just hanging off the front of the car, one at the back of the car, and one inside. And so the customer can in real time select which camera they want to be viewing from and get a significant amount of detail around how the car looks as they're making their decision around what to buy. From here, Toyota have got 52 retail outlets around New Zealand and a wide product range. So there's no way that they can get every model out to every store. It means they spend a lot of money in logistics and shipping cars around the country as well. So the idea is, if you can imagine that customers can go to their local store, they can put on a pair of VR goggles and see a full-size personalized Toyota car, drive into their vision, inspect it from every angle, and then virtually test drive it in the landscape of their choice. So this was a great example of immersive experiences. The last one that I'll talk you through is the America's Cup. So some of you may have heard of this. The America's Cup is one of the world's premier yachting events, but it's increasingly becoming a race of technology and innovation rather than just a boat race. So we partnered with Emirates Team New Zealand to look at how we could use 5G to enable the team to run multiple live video streams and real-time analytics back on base and help them make the most out of their day, buying them precious time. Now I've got a quick video, the last one, which will just tell you a bit more about the value for Emirates Team New Zealand.
The America's Cup is primarily a design race. Whilst we've got a really short time in which to make developments to the boat on the water, we need to make the most of that time that we can. What we've been doing in the previous campaign was capturing multiple videos and a huge number of data channels and logging that all to a hard disk directly on the yacht. Then at the end of the day, when the yacht was docked, we'd bring in that hard disk, get it up to the base. Now we've got 5G and we're actually streaming 5G direct from the yacht back to the base. It's made a massive difference to how we operate our day, because all those multiple streams of video and huge number of sensor channels that we're logging on the boat get streamed live back to the base. Well, what we're finding is that the guys who are not out on the water, so the bulk of our design team, they're watching the video and data live as we're sailing and actually discussing what's happening in the office and really thinking about what we're going to do the next day and the next week and looking at what changes we can make to the boat to make it more efficient. What 5G is doing for us is it's really enabling us to be dramatically more efficient and buying us basically one of the commodities that money can't pay for, which is time.
Hey look, I'm delighted to have 5G live on the water for Emirates Team New Zealand. It goes back to the promise we made over a year ago when we put the Spark Lab in. We talked about helping the boat go faster, and I think from my perspective 5G absolutely does that. This is a great example in helping Kiwi businesses go faster. If you think about it, transmitting data with precision at speed to improve how they perform, and I think about that in terms of what other businesses could be helped to compete against the best of the world.
Great, so that was just giving you a sense of some of the types of use cases that we're seeing. That last one there in particular is really interesting in the different capabilities, it's a bit of a mix of massive machine communication and significant numbers of connected devices and sensors. It's also very much about speed and capacity, and in future will be about latency as well. So if we think about 5G at Spark, how we're thinking about it is around delivering 5 key features that will help our customers to solve problems in new and unique ways. So we're seeing quite a lot of opportunity. We break it into these 5 features, and the ones that are particularly in demand at the moment, and the ones that we are seeing a lot of potential and interest in. Obviously, speed and capacity came up in a lot of those use cases, but the other ones that are coming through really strongly are edge computing. And the ability to take some of those, that AI machine learning type processing away from on-prem and on-site and take that back to the edge of the network is got some really interesting use cases. And also massive IoT as you start looking at as we start looking at the proliferation of sensors with smart cities, smart campuses and the like. So what we're doing next to help to support and enable innovation in the way that these features come to life for our customers, we're continuing with the approach of collaboration, but we're shifting focus slightly from our customers, our business customers, to working with small businesses and entrepreneurs in New Zealand to try and foster and encourage innovation in the 5G space. And so just very quickly, we're doing that through what's known as our 5G Starter Fund. And so we're in the middle of this at the moment. We've had several hundred applications of different 5G related ideas, and we'll be announcing soon who our finalists are for our Starter Fund. And we've been looking for that next generation of innovators. We've had applications across all of the categories that we've been running. So we've been looking for applicants in things like industry disruptors, next generation health, immersive experiences, and good for New Zealand, so that sustainability sort of angle. What we're doing at Spark is really partnering with our customers, now partnering with innovators and entrepreneurs of New Zealand, and we're very excited to see what 5G can do. And with that, I'll hand back to you, Rusafi.
Thank you, Renee. A wonderful presentation with the real use cases, with what we're seeing now in the current world. So now we will move back to the Q&A session. We will have a combined Q&A session for both of our speakers. So if you have any questions, you just kindly type into the question box in the control panel. We will try our best to discuss with the speakers. So I have started getting the questions. So first question I have got from Raj Kumar Mathai. I think Renee would be perfect to answer the question. So he asked that any delay of 5G deployment in 2020 to 2021 due to COVID-19?
I think New Zealand's been in a lucky position that we managed to move out of the lockdown phase for us relatively quickly. And so what that meant was we were able to continue with the 5G deployments as we'd planned. As I said, though, we have been taking a relatively phased approach that's really targeted towards where we see the value and how we can help New Zealand to understand what the value is of 5G. I think there has been a different scenario in other countries, though.
So the global scenario in the deployment, definitely there is a bit impact by COVID for the 5G deployments. When I say impact is not pausing the rollouts deployments. It's more about delaying the deployments. But however, the back shift, the thing what operators have taken is when the COVID is causing these deployment delays, the operators, the deployment and manufacturers, suppliers, consultants, they got an opportunity to review what they can do better way, how they can do a backhauling, how they can deploy the things properly. They got really a good time to rethink about their strategies and rethink about the deployment plans. And while still they continue to do, because maybe lockdown maybe caused a bit of delay, but it's not really stopping anything in the 5G deployments. But now it actually created an opportunity, and COVID indeed it's an opportunity for the mobile connectivity for every user. So that's the reason deployments are still going ahead. But next year, starting of next year, maybe after once COVID is over, the deployments will take rocket speed.
I think one thing we are seeing as well is a slight shift in some of the use cases. So definitely more focus in the health space.
Okay, thanks a lot. So the next question to Kiran from Raj again. Is there any special fiber specification like dispersion and latency required for the 5G fronthaul network where CWDM technology is used?
Yes, definitely depends on the deployment scenarios that we are planning. So you need a specialized fiber needs to be considered. So what is the frequency that we are, what is the transmission rates we are planning, and what is the radios, how many radios we are planning. Based on that, WDM technologies, WDM wavelengths, that depends on the lambdas, depends on the frequencies. Those fibers needs to be aligned. The fiber material, in terms of the manufacturing of the material, doesn't make any big difference, but planning of the equipment from the transmission unit to the radio unit, the connectivity, the connecting solutions needs to be specialized planned for the radio network.
Okay, great, thanks a lot. Our next question, I think I can ask to both the speakers. The 5G wireless network needs lots of fiber cables, definitely. But will fiber deployment patterns change when 5G is deployed? So do you feel, I think my question to both of the speakers.
So I take first chance to answer this question. So fiber deployments, anyway, if you look at a decade ago, 10 years back, the fiber deployments were very, very rare because the high cost deployment models, not much deployment models available, and there were no innovations for the deployment. But now look at the last couple of years, 3-4 years, because of the fiber to the home, FTTH, gone into the streets, inside the cabinets, streets everywhere, reaching each and every home, building infrastructure. While the infrastructure players or the builders, whenever they're doing, they are actually planning for the fiber. So now the fiber has taken advanced techniques to get rolled out. So when it comes to the deployment of the techniques, when it needs to be addressed for the small cells for the 5G network, yes, the deployments will differ. But however, the baseline, the backhaul still needs to be accommodated, still needs to be the same way what it was going to deploy. So the fiber, more and more fiber is going to come to address this ever increasing bandwidth demand by these small cells, 5G small cells. The deployments will take, and more innovations. Fiber manufacturers, fiber vendors, fiber consultants, they are actually doing innovative fiber deployment. They are doing innovative fiber materials manufacturing, so that the space and the occupancy is optimized. That way the deployments will be a bit different from the past days.
Yeah, I suppose probably just to add from my perspective, in terms of the fiber deployments and the ways that we're rolling out at the moment, obviously some of the characteristics of 5G, it's highly critical to have an extremely strong fiber connection that's got that shares the characteristics that we are requiring, such as the ultra reliability, ultra low latency, and the quality of service measures that we're looking for. The one thing I would say is that as we evolve towards an edge architecture, and as we start to move some of the compute capabilities out towards the edge, that might change the way that things are being deployed. And that's as countries move to more of a standalone architecture.
Okay, thanks to both of you. The next question I got from Chandan. He asked that share your views about 5G fronthaul, possible technologies and deployments. I think Kiran can cover that as well.
Yes. So as one of my slide touch based on the fronthaul options, so the 5G, whether at the moment, see 5G is, although it's a new exciting network deployment, but still it needs to be co-reside with a 4G LTE. The 4G LTE is already deployed, and predecessor technology 3G still exists in a few countries. So it needs to be taken account. It needs to be taken into consideration. So when it comes to the deployment of the 5G, so the same time it needs to be co-resided, it needs to be compatible with the 4G LTE technologies. So the deployments and the 5G along with the 4G will take place when it comes to the in terms of the WDM technologies. Fiber optics will although go more and more, but the technical aspects of the fiber optics will make more and more wavelength dense multiplexes. For the fronthaul, one option still can be considered the current radios, current fronthaul radio access network. Now the radio access network is also evolving into very advanced stage that consolidated radio access network, open RAN, open access network, radio networks. So the radio network still preferred fronthauling, but once the 5G is fully deployed, definitely the fronthauling should be with fiber backbones, fiber fronthauling. So that's the future that we are seeing.
Okay, great, thank you, Kiran. So I have a couple of questions based on your presentations and experiences. My first question is to Kiran. You mentioned some critical challenges about the site acquisition for the 5G small cells. So how do you see, basically, how can operators will cope up with this challenge? Because if in a dense populated country like India, Bangladesh, operator want to deploy 5G, so in this populated country, how do you think actually they will cope up with this challenge?
Yeah. So it's really a very good question, Rusafi, and it's indeed tough to answer your question when you said that the populated, denselated countries is really more challenging for 5G deployments. So that's what I said. It's a really very good question. So I have definitely answer for this. So before I straight away jump into the answer, I just want to share our experience that we are deploying in Australia. We are helping to deploy in Australia. So government, legislation, municipalities, councils, they are the governing bodies for deployments of the 5G. So the structure is such a way that it's aligned. The site acquisition, site survey acquisition is a key element before actually the deployment goes into the ground. So the acquisitions time when the preliminary designs are made, the preliminary designs are really submitted to the councils. Councils, they have certain timelines to verify, to get back. So the things are actually one way I can say they are aligned, they're proper way, they are actually in such a way process is aligned. But in a countries like highly denselated, highly populated areas where you want to densify the 5G radios, 5G small cell is really challenging. So in that challenging situations, the operators and governments should be a public-private partnership model, a PPP model, public-private partnership model. The building owners, community owners, building owners should play an active role to make this happen. So what I recommend is government bodies, the same time the public bodies, at the same time private building owners, communities coming together actually solve the problem of deployments, where this needs to be deployed, radios or small cells, where they needs to be deployed, how the backhauling. The powering issue is another very key aspect. So the powering, how that needs to be taken care. So all these things will be discussed, should be discussed, or should be addressed when it comes to the. So what I say is a coordinated way in such countries is one of the possible way to go to get the 5G rollouts more and more deployed.
Great. My request to Renee, if you could share your trial experience to this question, would be great in perspective of New Zealand's situation.
So in terms of?
So just continuing from Kiran, the site acquisition challenge, you already had some trials in New Zealand. So is there any challenges faced by your organization regarding this site acquisition challenge?
Yeah, I mean, I think site acquisition is always a challenge. In the way that we're deploying at the moment, we are generally adding 5G to our existing sites, so that helps. But we expect that it'll become an increasing problem, particularly as you look at future iterations of 5G and moving into millimeter wave, and therefore the need to densify then site acquisition will become increasingly important, but not for right now.
Okay, great. Okay, so my next question is to Renee again. I quite understand that your deployment plan is a bit delayed because of the COVID situation. So after it finishes, when you start afresh, will you go for an aggressive deployment plan or a trial-based deployment model?
So we haven't had much of a delay to our deployment from COVID. We've been lucky because New Zealand hasn't been locked down for very long. We had a lockdown through April, but since then we've been open for all construction. So we've been lucky in that sense. But we are taking a phased approach. That's partially because of the New Zealand government's approach around the spectrum. And so we only have short-term spectrum rights in the C-band at the moment. And so we're waiting for the long-run spectrum options as well. So it's a bit unique to New Zealand. But yes, as I say, phased, focusing on the areas of value. So areas where we've got business customers in particular who are wanting to trial the capabilities of 5G and following the value rather than trying to go for nationwide coverage too quickly.
Okay, great. So next question is from Bukhari Yahya from the Malaysian regulator of telecommunication. He has shown some interest in Renee's presentation on the project conducted by your organization. So any idea what is the minimum backhaul capacity required if they want to consider microwave as an alternative backhaul? Do you have any answer to this question?
No, I don't have the numbers to hand. At the moment, we're purely focused on fiber backhaul, and we are making sure that we've got 10 gig capacity as opposed to 1 gig at the moment. We would look at other options around backhaul probably in 2 to 3 years.
Okay, great. So I have another question regarding I think the most crucial challenge for 5G deployment, which is investment challenge. So to both of you, firstly, Kiran, how do you think this investment challenge will be coped up?
So you mean so when you say investment challenge, I can take that as an investment for the deployment rollouts, or the bringing the applications to realize the 5G. So I consider this from deployment point of view. So investments need to be planned very well. 5G, especially in this COVID situation. So last 6 months around the world, it's actually changed some of the perspective of the 5Gs. So when it comes to the 5G deployment related financials, deployment related planning, the planning needs to be done very well. That needs to be processed properly, and to make sure now we have time. So we need to see whatever we planned was correct or not. Just need to see. And it's a kind of, when I said highly denselated, highly populated areas, countries, or geographies. So when it comes to the public-private partnership, the financials also needs to be sorted out. How a long-term relationship model needs to be built. It's not only just from operator. So how of course we still have 4G, 3G connectivity, still mobile broadband is still going. But to make a long-term, to realize the long-term opportunities, long-term benefits, so the public partner partnership model, when it needs discussed, when it agreed, at the same time the co-sharing, co-profit sharing, co-revenue model sharing will actually address some of the financial challenges for the tier 2, tier 3 operators. So that's a kind of one of the model that we would recommend, that we have seen these models are actually very successful in some of the countries. So, but depends on the local legislation. If some operators, they definitely will have funding from their governments, so they can leverage their government funding to make it a socialized social network connectivity. The connectivity, enable the connectivity for the communities. So funding can be leveraged, and public-private partnership funds can be gathered, and private-public partnership long-term revenue co-sharing models can be leveraged. At the same time, equipment vendors or the manufacturers also, they are also showing interest to participate in such things, such a co-sharing model, so that they also have a role to play. So that they also can benefit for the funding model. So these are some of the models are recommended, but it needs to be discussed, agreed, aligned. But at the end of the day, the user should be able to experience the enhanced mobile broadband. That's the key.
Yeah. So Renee, based on your Spark's experience, do you see the investment as a challenge for the 5G deployment? And if you see how you are coping up with this?
I think investment is always a challenge, but it's a challenge around prioritization. And so that is part of the rationale for taking a phased approach, is to make sure that we can walk the tightrope between investing where we see value, but not over investing before the revenue actually appears. And so it's very much about understanding where are those opportunity and profit pools that we should be focusing our investment towards. I think there are some great examples of partnerships between government and telecommunications companies. We've got a partnership in New Zealand that's focused around our rural coverage, New Zealand being quite a large country that's quite sparse. So there is co-investment by the different telecommunications providers to provide coverage in quite rural areas. And so there are some really interesting models that you can help to, I guess, encourage investment, but it will always be a challenge.
Okay. So next question to Renee again. I have seen some interesting examples. You are working with the PayMark. So as security is another challenge for 5G application. So have you learned anything, and have you started to really going for action for coping up with this security issues of the 5G?
Yeah, and so I guess some of the use cases, and you can see these use cases all on the 5G Spark website, so they are publicly available. The PayMark one is an example where we ran that test in the lab on our 5G test network, so it wasn't a live use case or a commercial use case. But absolutely, that was one of the critical enablers of this, was the network slicing component in particular. So being able to create a slice of the network that would have the quality of service parameters that you'd need to support that type of service. And so think that would be significantly high security, but also ultra reliable, very low latency, all of those. So very high end network slice.
Okay, great. So just continuing to Kiran regarding this question, as an overall telecom expert, so how do you think the security issues will be resolved in 5G applications?
See, security is a major concern. So one side, the deployments and the things are going the one side, one direction. The other direction, actually, security is posing a big threat. It's actually the industry is in a big threat because the high ultra low latency applications, the speed of light, that way the 5G communications are expected. 4G LTE, 4G LTE, advanced communications to the 5G communications. Indeed, the security is actually needs to be taken care. So what the thing is, the network function virtualization, NFV, and edge computing, indeed they are actually enabling security threats. So that's the reason security, cyber security, security aspects are coming into this. So when the functions virtualized, when the network is virtualized, when edge computing is virtualized at high ultra low latency applications, the security is something needs to be taken care, needs to be deployed. So there are security companies. Actually, we are talking from Senko. We are talking some of the security companies, how the security can be indeed not only just in the software level, even in a hardware level, how the from physical layer to the up to network layer, 2 different layers, 3 different layers, how the security can be implemented. We are talking to some of the security consulting companies who are actually working with Senko. So that some security is definitely needs to be considered. So it needs to be taken care.
And considered early and upfront, right in the beginning design phase.
Yep.
Yeah, great. Okay, so the next question, I think Kiran would be perfect to answer this. One friend called Omar Rauda, he asked that with FTTH in building rollout, how do you see the interaction with 5G rooftop or in building cells? Specifically, he wants an answer from Asia perspective.
Okay. So when indeed fiber to the home is something that's already deployed, or in Asia Pacific, especially the ASEAN countries or Asia Pacific countries, you take any country somewhere, rest of Australia and New Zealand, if you take these countries to separately, or if you take rest of the Asian countries, the fiber to the home is really in advanced stage. The next aspect in the fiber to the home is the fiber to the buildings, MDUs, multi-dwelling units, high-rise buildings, HRBs. So that's another area the fiber also gone into the buildings. So bringing 5G to the buildings, inside the buildings, inside the apartments, inside the even residential or even enterprises, commercials, when you have a fiber there, it's very easy because you have the front hall that requires to carry that much of bandwidth, and you have the infrastructure already deployed. If at all the broad fiber is not deployed in such buildings, it's still under rollout, but still 5G needs to be addressed. There are again still techniques, there are still technologies to mix the hybrid. In one of the slides I have shown hybrid techniques using the RF components, RF network, RF antennas, at the same time using the fiber optics. So it depends on that, depends on the infrastructure availability. And some countries, especially I've experienced in Asia Pacific, even you don't have the space in risers to build, to connect the antennas, to connect the infrastructure, even to connect the equipment, the radio units. So issues are the feeder, front haul feeding, at the same time the powering. So that's the reason Senko, we actually innovated some of the hybrid connectivity solutions to make more compacted areas, how the hybrid can be through AC power to DC power, at the same time light transmission data transmission, power or Ethernet transmission, different technologies we actually invented from our labs. Those solutions techniques are available in the market and can be leveraged based on the network planning and design drawings.
Okay, great, thank you. I have one more question. This will be the last question for today's webinar. I think this is from Raj again. He is based in Netherlands, and we have seen some news that the 5G towers are being burned in UK and Netherlands in the news. So my question to Renee regarding this, how to prevent this through more education. Are we really doing enough in this area?
Yeah, we have this conversation quite a lot at Spark. We've had the same situation in New Zealand. There's been some arson of cell sites. Generally, the arsons are not 5G cell sites because the arsonists can't tell the difference, which is interesting. I think from an education perspective, absolutely we could, as an industry, we can always do more. But part of the challenge is that we need the support from government and from media to help to educate people and help to stop the spread of fake news, particularly because as much as whatever we say, we're always going to be coming from a biased position. So making sure we've got the science and regulators to help reinforce the right messages is really key.
Okay, so Kiran, do you have anything to add here to this question?
Please. See, look, any radio transmission equipment or any equipment, any electronics has the interference, has some radio frequency, so it has something. So we've been experiencing from 1G to first generation to up to fourth generation. We are talking about fourth generation advanced LTE. We're talking about more high frequency devices connected inside the home, everywhere. So I really don't see what 5G makes difference in terms of that. That's our experience. We generally don't see the difference in terms of that particular point. But however, as Renee said, it needs to be, government needs to be supported, and there should be some legislations that actually make more education about the technology. And indeed, at the same time, I'm coming back to again to the equipment vendors, manufacturers. So they are actually they are looking future as a green environment. So when they make the equipment, when they prepare the manufacture the products, they actually look into that aspect. They actually keep that in view, and they have a lot of lab testing, rigorous testing before they release the equipment outside the market. So with this scenario, I really don't see that's really something harm to the environment. So definitely, this is not going to be. I mean, in our view, in our expert view, we can say it's not going to be anything challenge in the future.
And I think that's part of the challenge, right? A lot of us are engineers, and we're coming at this from a science and logical perspective, but we need to make sure that we're getting the messages heard in the right way to the right people.
I agree.
Great. Thanks to everyone. Firstly, I would like to thank two of our distinguished speakers for today for their immense support for FTTH Council Asia Pacific's webinar initiative. We really thank you both for having your time here today. So thanks to everyone else, and we will keep this initiative going on, and in future hope you will be touch us again. Our next webinar is in the display. It's on 29th of September on the invisible footprints, a clear solution for FTTH from Corning. So please stay tuned through our social media pages in LinkedIn, Facebook, Twitter, and YouTube. And if you have any feedback regarding this webinar or the total webinar series, please welcome. You are welcome to put out any comment and any other thing. So thanks to everyone again. Thanks for your time. Thanks to Kiran, thanks to Renee. Great.
Thanks
We'll
for
catch up.
everyone.
Thanks for having me.
Yeah, great.
Bye-bye.
Thank you. Bye.